Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student, last time we had started discussing fuel cell and some of the major challenges of the fuel cell. Now today we are going to proceed a little further and we are adding some more stones in order to uncover some of the facts and some of the challenges that are facing to the fuel cell. So just to remind you that last time we had discussed different type of fuel cell. The first one that we had discussed a phosphoric acid fuel cell. And I told you that the first one which was commercialized was phosphoric acid fuel cell. And I'm dead sure that you people remember the basic construction of fuel cell and the basic problems which are facing to the fuel cell. So phosphoric acid fuel cell was the first one which was commercialized. And we had discussed the details of phosphoric acid fuel cells. That what's happening at cathode, what's happening at anode, and what's the major role of phosphoric acid inside the fuel cell. Dear student, keep in mind that whenever you are discussing something, so you should be directly addressing the issues which are facing to that particular subjects. For example, if you are discussing phosphoric acid fuel cell and alkaline fuel cell, so first you need to discuss the basic structure of a fuel cell and then incorporate that where phosphoric acid is used in that fuel cell or where alkaline is used or where potassium hydroxide is used in that cells. The second point, you should know about the working principle of fuel cell, and that's almost common. And we had discussed that things in great detail, that what are the major components that are common in all fuel cell, irrespective of the nature, that either it is phosphoric acid fuel cell or it is ethanol fuel cell or methanol fuel cell or it is solid oxide fuel cell. So that was our discussion, and we had just reached up to proton exchange membrane fuel cell. Now again, I told you that there is a comparison every time between fuel cells and batteries, and there are some also very good review papers which are written before 2005. They have compared different energy sectors. And basically, the energy materials are the energy devices. If you broadly classify all of them, so you have just to divide into three different sectors. The first one, you should put a batteries, second, fuel cell, and the third one, supercapacitor. Now, keep in mind that basically there is a big difference between batteries and fuel cell. Again, some of our friends, they are still discussing these issues, that fuel cell is superior or batteries is superior. So it depends upon on the total cost, its output, and what's its operation, and what's about its efficiency. That's why we had just added efficiency over there. So here I will try to remind you some of the basic points, that some things that you see in the market very easily, and even in every person, every individual have access to that accessories, and these are batteries. But what about the fuel cell and what about the supercapacitor? So these days they don't have any established market positions. It may be possible that in the future it replaces that as often as batteries are used, but not at the moment. because the fuel cell are still at the developmental stages. I told you, uh, it has proved its application in different sectors. Like we had discussed in the previous lecture, that in Apollo and Gemini space programs, we had discussed that it was used successfully. And the major success of the fuel cell in comparison to internal combustion engine or in comparison to gas turbine is that the fuel cell mass is almost less than 500 to 5000 times if we are using a same power source of 100 kilowatt hour that we had discussed last time. So there is a comparison and there is a competition between fuel cell, supercapacitor and batteries. And it may be possible that in the future that the fuel cell and supercapacitor can compete and replace batteries. Basically, a fuel cell intend to replace combustion power sources due to possible high energy conversion efficiencies, and that is quite alarming for internal combustion engine and for also turbines, that they cannot compete with the fuel cell if still there is a big if, that if we are able to remove some of the discrepancies which are some of the fundamental defects in the fuel cells. Of course, there's a hard reality that no one can deny, that fuel cell cannot compete today with the combustion engine and gas turbines because of its much higher cost, its inferior power, its energy performance, and insufficient durability and lifetime, because its operation time is less than 3000 hours. So that's also very important. Okay, there is some confusions that most of the students, they are still discussing that. Basically, whenever you are not in a field, so its terminologies seems to be a little weird for everyone. And keep in mind that sometimes we are using watt hour per kilogram and watt hour per liter. So basically, the specific energy and the energy densities, these are the terms that we are regularly and frequently using that. Now, if we are going to compare, that's a big question. I need the attention of all the students. That's a big question that if you want to compare the power and energy capabilities, how we can do that. So basically, there is a very fine and very interesting plot that maybe I had shared with all of you sometime before from one of the papers that was published in Chemical Review in 2004. Again, I'm sharing for the sake of its advantages. It's really very important that if you just compare here on your y-axis, there is a specific power. And I told you that specific power have the unit of watt hour per kilogram. And we have also the specific energy on your x-axis, that is watt hour per kilogram. So you can just compare. Now there is a big difference between fuel cell, supercapacitor and batteries. And on the right top corner you can see combustion engine, gas and turbines. So that's also very interesting that looking to this figure, that looking to this figure we can easily find out that there is also here, you can see here that is combustion engine and gas turbine. Basically our whole market is manipulated by this combustion engine and gas turbine, although they have a lot of shortcomings as well. Now, if you look at this figure, it's very easy to understand that on one side, the specific energy of the fuel cell is much more higher than batteries and supercapacitor. And just Being as a layman looking to at this plot, that this plot is called Ragon plot. And in this Ragon plot, you can easily understand that if I'm just coming on the x-axis and the value is increasing regularly. So the first number is a supercapacitor. That first is the supercapacitor. And the second one is the batteries, and the third one is the fuel cell. So it means in comparison among supercapacitor, batteries, and fuel cell is on the top. Now keep in mind that basically the difference between the fuel cell batteries, it's very easy and it depends upon on the chemicals that you are going to supply. I told you that batteries, basically the chemical is confined in a sealed container. So usually the capacity is measured in ampere hour, okay, and it's determined by the quality of the chemicals it's hold. Higher the chemical, higher will be its efficiency. Lower the chemical, lower will be its capacity. So it totally depends on your chemicals that you are using inside your batteries. What about fuel cell? So basically fuel cell and batteries, uh, chemicals supplied from the external reservoir. It totally depends. There is no storage devices inside the fuel cell. You should put the fuels outside and you are continuously fueling it. So there is a term that usually used for recharging of batteries, but we never use recharging of fuel cells. We use refueling of the fuel cells. Batteries, you can recharge it. It is charge, discharge, and some are rechargeable, some are not rechargeable. We are not here to discuss that things. It's really very interesting that if we have opportunity, we need to discuss that also in great details and particularly its research perspectives. And there are some groups that they have really very advancements in that field, particularly in lithium-ion batteries. Maybe at the end of this presentation, I would share some of that new research with all of you, that what's going on. So being as a good researcher, you need to have a quick look to all different fields at the same time. That what's going on in the improvement, advancement, enhancement, and development of the fuel cell in the batteries and also in the supercapacitor. But you should never neglect the improvement in a combustion engine and gas turbine, because all those scientists who are working on the fuel cell, so they are restricted to its improvement. But those one who are working on the combustion engine, and these days we have hybrid technology, and why hybrid technology is much widely acceptable and it's used. It fastly growing technologies, and they have completely covered the whole market. So you should keep in mind that batteries and fuel cell is fuel from the external reservoirs that you need to supply them. So for this reason, fuel cells are rated by their power output measured in watts like that. So that's we had discussed last time. So every time you are using the fuel in the fuel cell, that is hydrogen and that is methanol and there are some other hydrocarbons, they are different and that we will discuss later in great details. But batteries basically they are using inorganic compounds like metal and metal oxide that we had discussed last time. If you just remember, that's really very good. The second point that I want to discuss over here, basically the fuel cells were intended to replace combustion power sources. Okay, so you can just look a quick look to this plot now, that on your left hand side, just I'm talking about on x-axis discussion, on your left hand side you have supercapacitor, on your right hand side you have fuel cell, and above that you have combustion engine, which simply means that the specific energy of the fuel cell and combustion energy are comparable, are same, we can say like that. More simply, they are almost same. But if you are looking to the specific energy of the supercapacitor, it's much more lower than that. Okay, that's a one sort of discussion. So the second points and the what about batteries? Now batteries is in between fuel cell and supercapacitor. Okay. Keep in mind the working principle of the supercapacitor is not same as that of batteries and fuel cell. If you are more interested, you can go through the super. There are some good reviews that are written on the supercapacitors, and they are charged basically storing devices. Okay, while batteries and fuel cell, batteries can also call a charge storing, but the fuel cell is conversion devices. They are just converting. So if you look on the y-axis, on the x-axis, there is some region, overlap region. Because if you look here, the fuel cell started at this point, okay? But the battery is going to finish here. So it means that this area, which is I'm going to encircle with a red line, this area is overlapped area in energy, okay? Uh, and also if you look at other sides, on your y-axis the specific power. So regarding specific power, the highest value is that for capacitor, like this one. What about the fuel cells? Fuel cell have the lowest one. Batteries is above that. And the supercapacitor. If you just look at a combustion engine, so combustion engine have specific power, highest specific power. Okay. So just from this figure, you can easily evaluate that which one of the system is much more better, that have better specific higher specific energy and specific power, which one is the best one. So it's clear that we know that specific energy we are coming on this side, so we have this combustion engine, and we have specific power, again we have that combustion engine. Although on one side we have fuel cell, on other side we have supercapacitor. In specific energy sector, fuel cell can compete with combustion engine, but on the specific power side, supercapacitor can compete with that one. Okay, now it's really very interesting, and that point is that there is no single source, that is fuel cell, batteries, or supercapacitor, that can alone compete with the internal combustion engine. Okay, that's the first point. The second point, that still we have a long way to go to compete with the combustion engine, that on the specific power basis or on the specific energy basis. If you want to compete uh, between the combustion engine and the competitor is a fuel cell, then you need to improve its specific power, that we had discussed, that its specific power operation time is quite less, so its durability and the performance, and there is some serious problems regarding fuel cell that we had discussed, and by the whole of Allah we will discuss also in this class. So there is no single device that can compete alone, but still we have a lot of windows open over here, that if we can make some batteries, because batteries of thin film electrode exhibit power characteristics similar to those of supercapacitors. So if you just look here, okay, first let me just clarify this point, because the overlapping region, that's also maybe a serious problem for some of you, that why there is overlapping region. So regarding this discussion, you should keep in mind 2 points. The first one, only fuel cell cannot compete in the current situation with the combustion engine. Only supercapacitor cannot compete with the combustion in the current situation according to this graph. Okay, and then the batteries, you know about this. So one is the comparison of combustion engine and supercapacitor, combustion engine and batteries, combustion engine and fuel cell. The second discussion is you should look at the fuel cell, batteries and supercapacitor, which one have highest specific energy and which have highest specific power. Okay, that's a very simple discussion. The third one, is it possible that fuel cell can compete? No. at the current situation. So what we need, where is the window open for us? So fuel cell reach to its maximum value of specific energy. We don't need to improve that. What we need to improve, we need to improve its specific power. So that's a very open discussion. The second, if you are working on the fuel cell, so you should focus on that sectors. So if your goal is very clear, then it's very easy to proceed or to find out the solution. Okay, now if you are working on supercapacitor, then what do you have to do to increase its specific energy? Either to fabricate, add a material, or to change some of the basics inside that, and just to improve its specific energy. So that's very interesting. Okay. Now the question is why there is a overlap region between supercapacitor and batteries, and why there is overlap region between batteries and fuel cell. Now the first one, there is some overlap uh, that is on the both sides, okay, on the energy side and the power side. I'm not discussing because if you look here, this area, this is this one, the red one that I'm going to cover. Okay, this area is the overlap. Now this area is not only restricted to the specific energy side, it's also shared on the power side as well. Now what does it mean? Now batteries that with some thin films electrode, they exhibit some characteristic, and that characteristic too is related to that of supercapacitor. So that is why we have a here overlapping region. Okay, this one. The second point, there are also some hybrid systems, that is metal air batteries. People call them MABs, metal air batteries, and some metal air fuel cells, in other words, which contain a battery electrode, metal electrode. So that is why there is a characteristic similarities over here. So which simply means that batteries on one side have some characteristic to the supercapacitor, on other side to the fuel cell. So there are some uh, characteristic common between batteries and fuel cell and batteries and supercapacitor. But finally, we got the one point from this plot that there is no single electrochemical power source can match with the characteristic of internal combustion engine. Okay, so high power and high energy. So that is the need in comparison to combustion engine. That can be best achieved when we can just mix or make some hybrid system which contains some of the characteristic of the fuel cell and supercapacitor. Because on one side we know that the specific power of the supercapacitor is very high, so that is the best one. Another side we have fuel cell. So such hybrid electrochemical power scheme, that is batteries and our supercapacitors, provide high power and they can deliver a high energy. So these are some realities and some facts that you should at least know. The second thing that I want to share with all of you who are here, that whenever you are studying something like fuel cell, batteries, combustion engine, so you should keep in mind and you should have to read the most updated papers regarding particular subjects. That's very important. Okay, so we are going to extend now step more towards the fuel cell. So fuel cell, as we had just discussed now that efficiency is very high, so we have no problem regarding that. Now, how it can achieve a high efficiency? So that's a problem. If you just remember, I told you that Francis Bacon, who was a pioneer in the specific field of fuel cell after its invention, because as the fuel cell was invented first time, so I told you that after its invention there's a little improvement, and practically that was Francis Bacon who had taken a step, and he had worked and devoted his whole research to the fuel cell. But if you remember one of the point of his own research work, he has restricted himself to only hydrogen. Okay, so he used hydrogen and he used oxygen as an oxidant. Now here, it's really very interesting that the energy of every energy system is totally depends upon on the fuel that you are using. If you are using a high quality fuel, so it means you have high energy output. If you are using low energy, so it means you have a low energy output. And that's the reason that I told you that chemicals that are used in the batteries for energy conversion, from that we can easily find out it's that either this is a good battery or that is a bad battery. How we can decide that? So that is basically I told you that it is the chemicals that they are used over there. So here, if you are using any fuels, so basically if you look at the function of the fuel, and if you just keep in mind the first figure that we had discussed in the previous presentation, that is a structure of the fuel cell. So basically there is a hydrogen coming, and that hydrogen is going to convert into protons. Okay, so that conversion into proton is called oxidation. Simply, if I just combine and just summarize this whole discussion, so it simply means that fuel is going to oxidize. Okay, how it's going to oxidize? Because we are removing electron from that fuel, that is from hydrogen. Particularly, I'm just pointing this hydrogen now. So if we are going to remove that electron from there, that is called oxidation, and that is the reason we call them hydrogen oxidation reaction, HOR reaction. Now, it simply means that we can use any kind of chemicals which is available to us, irrespective of the nature. It is a hydrogen, it is methanol, it is ethanol, any hydrocarbons, we can use it. If we are able, or if our material that is used in the fuel cell on the electrode, it is our catalyst, they are able to take electron from that and convert into some other products. Now we are not concerning about other products, we are just concerning about that electrons, because that electron will move through external circuit and responsible for electricity. So when these electrons are responsible, so now it's the whole scenario become very easy and very clear to us. Now the picture is very clear to all of us that the basic purpose of the fuel is to give electron. We can take electron from any chemicals because we know every element in this universe having electrons. But the problem is which kind of fuels we can use. So that's a problem now. So we have also to follow some of the rules, regulation, some code of ethics, and some community responsibilities, some individual responsibilities, and some combined responsibilities. Because we are not going to take only the benefits, individual benefits, as some of the human beings are doing these days. They are so-called human beings. They are not in the category of the human beings, because if you are working on some sectors and your work is not for the benefit of the humanity, and you are not working for the welfare of the society, so that's of no use. No matter that you are a billionaire, or no matter that you have a lot of wealth, or no matter that you have a lot of degrees, PhD, doctors, and so many degrees, but still, if you cannot work for the welfare of the society, is of no use. So you should keep in mind some of the society responsibilities. No matter that you are working in a scientific laboratory, you should keep in mind. The second point, and under that topic, everything is covered. There's environmental impact, hazardous nature, its toxicity, and so many other things. The second things you should keep in mind that what I'm using is available or not. Okay, if it is national wide and international wise, it's equally available and accessible to everyone in our current infrastructure. For example, if you are giving an idea of using methanol as a fuel, so first you should think that either methanol is available or not. If it is not available, that it's okay research wise, that's a great idea that you are going to give the idea of some fuels that it can be used as a best fuel. But if it is not available, or it's available but that's not easily available, then that's not a good kind of fuels that you are suggesting. Maybe that's one of the best research, but that's not a commercializable or implementable fuel. Okay. The second point about its cost, and that's material art. But keep in mind, this cost is comparable in most of the cases. There is no absolute cost that we can say this much. Okay, that's a comparative term. So I'm giving you the example, then you can understand very easily. Cost is something that you can compare, and you can just say in some of the countries, some countries, they cannot compromise on the quality of the material. But some countries, they only need the material even with a low quality. So the cost, for example, if you take some of the laptops, cars, and some electronics, so which are used in some countries, most of the people using that, but in advanced countries they are not using that. The reason behind that is the cost is a comparative term. Something you cannot afford it, but some other bodies can afford it very easily. But whatever we are discussing in case of fuels, cost, it maybe it must be the average value, that if most of the human beings can easily afford that, then we call that is okay, that is economical, no problem. The third one is toxicity. If you are working on the fuel cell, or you are working in the supercapacitors or battery sectors, and your fuel cell is generating some toxic chemicals that are hazardous to the human health. Let me add here some related information to that. If you look at mercury, if mercury is the most toxic one, if you compare the list of toxicity, if you just WHO data for the toxic elements, you will find mercury on the top. Then we know that mercury exists in the two different forms, organic or inorganic form. And we know that the most toxic one is the organic form of the mercury. Now, okay, how this organic form of mercury is a toxic one, and from where we know that? So basically, there was a fertilizer industry, some Japanese fertilizer industry, and the effluents of that industry was organic mercury and Minamata. Okay, and there, just after a few time later, just they realized that the effluents coming from the industry is affecting all the life of human beings, and also affecting the life of all animals, even plants, and some other animals, not the human beings. So it means that the toxicity of the mercury has a broader range. It can affect a human being, it can also affect the animals as well. And then University of Minnesota conducted some research on cats, and they injected methyl mercury, some organic mercury, to some cats, and they are really very toxic. And then they realized that, okay, the basic reason for their toxicity is the methyl mercury. They confirmed that. So if you are working on some sites, or a supercapacitor or batteries, and people appreciate you that, okay, you are doing a great job working in energy sector, but you are producing some highly toxic chemicals. So instead of giving benefits to the society, you are also make the life of people in danger. So that's really very important. As I told you, there are some ethics of research as well, and there are some responsibilities. Of course, it may not be the in a specific book that you can go and find out a book that I want to find out that what is the ethics. But being as a human being, there is some common human responsibilities on everyone. Okay, the fourth one that I have just shared with you, that is a calorific value. If you are using a fuel and the calorific value is not good, so I think most of you people are familiar with this term, so I don't want to discuss in details. Okay, the second one is the storage, gravimetric and volumetric. If you are using a fuel and that fuel is not toxic one, and they are not very expensive, it means that the cost is okay, compromisable, and it's available, but still they have a storage problem. You cannot store it, or if you store, that's a dangerous one. So again, you cannot use that. And there is a fuel cell performance. Okay, so if you are using a fuel and that fuel can give electron on the electronic material, but rest of the chemicals, they are toxicating or they are poisoning the catalyst. So again, that's not acceptable. That's only one factor that I have discussed. There are many factors that you can take into account and the fuel cell performance. The second one, because the basic structure, if you uh, keep in front of you the basic structure, then it's very easy to discuss the issues over there. And if you remember that there are two electrodes, there is a medium. So if your chemicals that you are using as a fuel, they are coming to the electrodic material and they are giving electron very fast, and they qualify all the qualities of a good fuel, but they are releasing some chemicals. They are going to damage the medium, that is a membrane, or that is a that is a liquid, or that is a solid. They are damaging that connecting membrane, connecting medium. Then again, it's of no use. So that's another sector that you can say that fuel cell performance. Okay, and effect on performance degradation. It's also very important that whenever some chemicals are releasing from your fuel cell or from your energy sector, so it must be degradable. If they are not degradable, so then they will accumulate on the whole society and the whole atmosphere or on the soil, and they will cause a pollution. And we know from the day first that as the technology, there is advancement in the technologies, so it makes the life of a human body, not only life of human body, but plus life of the all species in danger. And the reason is because we are toxicating the whole environment. So that's is very important. And you should also the phase, that which kind of phase you are using. For example, if you are using gaseous phase fuel, or liquid fuel, or solid fuel. So about you should know about the basic idea, the energy density of the gaseous, liquids, and solids, and on that basis. So if you have the idea that okay, I'm using that gas as a fuel, but it can easily be converted into liquid or solid. So that's a super idea, and well accepted everywhere. Okay, then water content or other non-reacting species such as carbon dioxide. Okay, we know that in the fuel cell, our byproduct was just only water. So if it already contains water, so uh, there is a alarming sign that is it not going to flood our whole system? Okay, or corrode some of our chemicals inside that, because the environment inside the fuel cell is very toxic in that sense that all the chemicals we are using as a catalyst, they are highly active. So if there is any carbon dioxide coming to that electrodic material and they are depositing on that, so our catalyst will be of no use. And the last one is security of supply, carbon content. That's also very important. That's thing that you should keep in mind. So this whole discussion, I'm not sure that I'm going to just pushing you in some other directions, but basically these are very important, that which kind of fuels you can use and what are the parameters that you should find out in a fuels. So these things you should keep in mind. These are not the complete list, they are some of them. You can add some others. As I told you, that the basic scheme will be some scientific advancement, some your society responsibilities, individual responsibilities, and community responsibilities, and some research ethics as well. Okay, now coming to their sides now, you have a general idea that the basic purpose of the fuel, what is the basic formula? You can easily answer this question now, that why we are using a fuel and what is the basic aim of a fuel. So that is the main reason that every time I am focusing on one point, that you must know about the working principle. If once you know the working principle, then it's really very easy. That's like a peanuts for you to discuss or to work practically as a research student in that field, because you know the working principle and you know that which point I need to address. Okay, so that's really very easy. So technically anything that can be oxidized at electrode can be used as a fuel in a fuel cell. And now I think that you face no problems in understanding this line. So there is a broader range beyond hydrogen, because Francis Bacon has used hydrogen. You can use anything, okay? And that anything's, I told you that you must need to qualify your fuels and the qualities that we had discussed. You can use gasoline, you can use jet propellant, diesel, biodiesel, and propane, biogas, ammonia, methanol, ethanol, and butanol. Because all of these chemicals have the ability to be oxidized and releases electron. So when they have that quality, then we have no question in discussing that we should use that or we should not use that. So there is no question regarding its fuel ability. Okay. Now, okay, that's compilation of what we had previously discussed, and you can easily understand that which kind of fuel we are using. And basically here I'm just starting from the left side, that on the left side if you look at here, that is our alkaline fuel cell. Okay, that is here, that is alkaline fuel cell. But regarding temperature, they just tell you about the whole general idea of the fuel systems. Okay, because we know that fuel cell is not only hydrogen fuel cell, is not only solid oxide fuel cell. We have phosphoric acid fuel cell, we have alkaline fuel cell, we have proton exchange membrane fuel cell, and we have ethanol fuel cell, we have methanol fuel cell. There are broader range, but here on the basis of temperature wise. Okay, so if you are using a fuel cell and you can provide a temperature of 70 degrees centigrade, so you have a best option of alkaline fuel cell. So they give you operating temperature and common fuel type. So which kind of fuel you are going to use, supposed to use? You have to use hydrogen as a fuel. Okay. Now they, if you just uh, take like this, they give you the whole idea now, that basically there is a fuel, there is a anode, electrolyte, cathode, and temperature. Okay, and what these material will interconnect. So basically fuel you will use an alkaline fuel cell, hydrogen. Your anodic material will be made of platinum or nickel. Okay, if you remember, so Francis Bacon worked on the nickel electrodic material, because he believed that platinum will never be commercialized. The second one, electrolyte. So now you have the general idea that electrolyte is alkaline. Okay, it may be potassium hydroxide or it may be uh, sodium hydroxide. But you should keep in mind that why we are using sodium hydroxide and potassium hydroxide. Here is a very simple question for all of you. Okay, if I'm using platinum, so platinum is the best catalyst for fuel cell as an anodic material in alkaline medium or in acidic medium or in neutral medium. Okay, and you need to respond me no matter, that's not a question that you can get marks by that, but I need to know that either you are understanding what I'm going to teach, or there's something that we are just above, floating above your mind. So you should also need to focus on some things. Okay, I'm repeating again the question that everyone in this class, you know that platinum is used as electrode material, particularly as a anode material. So I'm asking this question again, that platinum is used as anode material in the fuel cell. Is it a good material in alkaline medium, acidic medium, basic medium? In which medium it acts as a best catalyst? Okay, that is the first question. The second question, that you should respond me on that WhatsApp group or in the stream comments, is okay. The second question regarding that, you should also know that either we are using any other metal. For example, I will take a case of nickel. So is it possible that nickel is the best catalyst used in fuel cell uh, in acidic medium or basic medium or neutral medium? So just tell me 2 points regarding platinum, nickel. Okay, let me add one more, palladium, Pd. So palladium, which one of these show best performance in which medium? Okay, if you are just referring to platinum, you can tell me it's a best catalyst or a stable one, or high activity in the fuel cell in alkali medium. If you are comparing the palladium, then you can also tell me that where it can be used. And nickel, so what's the scenario of the nickel over there? The second one, you should, if you are increasing the temperature, because that is the construction, and you know it's very easy to construct a fuel cell just from anode, cathode, and electrolyte. But you should know also the temperature as well. Now the second one, you know that that is a polymer exchange membrane or proton exchange membrane, and that is a methanol or hydrogen. It can, you can use as a fuel, and that is for 80 degrees centigrade. So if you are increasing the temperature, again you can use hydrogen. You have the option to use hydrogen, and you have the option to use methanol as a fuel cell. Okay, and what will be your anodic material? Anodic material is platinum, and the polymer membrane that we had discussed last time, not in great details. If you are interested in that polymer membrane fuel cell, so there are a lot of good reviews that you can go through and study that. Okay, just for your information, if you are interested in any of these fuel cells, so there are particular self devoted review papers. They are completely devoted to a particular subject. You can go and study that. As a cathodic material, you will use as a platinum. Okay, and the temperature more than 80 degrees centigrade. Now, again, if you are using a higher temperature than that, if you remember that we had studied that, if you are using 200 degrees centigrade, you need to use, that is a phosphoric acid fuel cell. And for that, we are using hydrogen as external reformer, and we had discussed that, because I think that in that presentation, our revolving point, a major topic of discussion in that was phosphoric acid fuel cell. Then we had given a little bit concentration to the alkaline, and then due to the shortage of time, that's a basic problem for us every time. Not the first time, that whenever we want to study something, and there is a very famous Arabic proverb, لكل شيء آفة وللعلم آفات. Uh, so every time I'm facing the same problem, that I want to discuss a topic, so there is a shortage of time. But luckily, uh, today we have a lot of time, so we can discuss everything very clearly. Because according to my nature, I don't want to keep anything in complexities or ambiguity or any confusion. So just to clarify each and every point in every presentation, and of course it need time. And that's a complaint from most of the students, that the lecture is very lengthy. So If you are just reading a book, of course, you can read it. But if you want to understand, so you need also to focus on some other sides, and you have to connect some supporting knowledge to their topic as well. That's really very important. So that is the construction and working principle of that phosphoric acid fuel cell. You can just look at here, and you know that here, what's happening? Electrolyte. Uh, this electrolyte is going to transfer the proton from anodic to the cathodic material. That's really very interesting. The third one is you know that it is a molten carbonate. Now, that's we had not studied till now. We will study if we have opportunity that in details that which kind of fuel cell that's work at 650 degrees centigrade. So at least you should have the general idea that it's not similar to that of alkaline fuel cell. It's not similar to that of because this region is totally different. Okay, so now you can just draw a line between here that if you are using above 200 degrees centigrade, you have total different scenario, and if you are using below 200, you have total different scenario. Okay, here you are using some interconnect as a metallic. In the previous one you had used graphite, carbon composite, metallic, graphite, different interconnect, but here you are using metallic one, and you are using the fuel uh, as a hydrogen, as a carbon monoxide, and as a methane. Okay, here again I want to ask another question. That is a third question after today lecture. Can we use carbon monoxide as a fuel or not? If yes, then why? And what will be the mechanism for that? Okay, that's a very simple question. You can answer me anytime. You have free option, but at least try to convince yourself first and then try to convince me. Is it possible that we can use carbon monoxide as a fuel? And if yes, then how? And if you are convinced, then why it's not using? Okay, so and then we are using a anodic material nickel alloys, and we have what are the material they are going from one side to another side. One side and another side, I means that from cathode to anode or from anode to cathode. So here you can see that from cathode to anode there is a carbonate ions moving across these electrodes, okay, in the electrolyte. And if the temperature need is 650, it means for a special purposes you can use this kind of fuel cell, and for general it's not applicable. And the reason is because 650 is a very high temperature. And here the solid oxide fuel cells, you can see that here hydrogen is used. Now you can, again there is carbon monoxide and methane also. Okay, and then you can see here what's going. There is a nickel again used as a node, and there is a lanthanide series. You can take anything from lanthanide series, and there is a lanthanum compounds, lanthanum niobium and lithium niobium. There are some a lot of research in that sector, particularly in this specific field that people are focusing on there. Okay, here because most of the students they are also from different backgrounds, so I'm just giving you the clue over here that no matter if you are from any background, you can work on a fuel cell in any factors. You can work on that electrolyte, you can work on anodic material, you can work on a cathodic material. Why I have put it this slide for discussion, the reason behind that is if you have this slide and you understand that, you can easily choose a research area for yourself. Now, okay, you may ask that if anybody from inorganic sides, how he or she can do a research in that sectors. You can just look here. There is a lanthanum based compounds. You can prepare a lanthanum based compound and you can find out its cathodic property in the fuel cell. It's really very easy and very interesting. You can prepare, and there are a lot of review paper in the Royal Chemical Society, in Chemical Society review, particularly Chemical Society review. I'm not sure about the chemical review because I came across a few papers and most of them are from Chemical Society review. and that is a journal which have a very high impact factor. I'm not sure that it's more than 50 or around 50, but it's almost around 50, and it's publishing the article since 1972, which is not the age of anyone, I think, in this class. So it's a very good review journals, and it's a very high impact. But again, here the problem is the paper is a little bit lengthy. Some of the paper are 50 pages and some are up to 75 pages. So again, I will just say that there are no free lunches in the world. You need to give time and give money and give your full attention, then it's easy to understand or to do conduct some research or to achieve or to do something for the welfare of the human being. So if you are an inorganic chemist, you can easily work on that sector as well. That is an open field. You can just prepare some material, lanthanum based material, and then you can use its catalytic property as a cathodic material. Why I'm repeating that terms? The reason is you don't need to focus anything else as anodic anything else. You need to only focus one, and that is a single experiment. If you are using to find out its cathodic property, okay, uh, and that's the basic chemistry. Anyone can do that. Now again, I just want to take a 1-2 minutes, and then I want to move forward. You can look at here the electrolyte and the function of the electrolyte. You easily understand the function of anode and the function of cathode. That's not a problem for you. Until now, you also know about the function of the fuels. That what basically fuels are. What's the main purpose of the fuel? That's very easy for you. Now this electrolyte, you can see in alkaline fuel cell what happened. The hydroxyl ion is moving from cathodic material to the anodic one. And if you remember, hydrogen is in the reverse of that. So they combine and they can give you water molecule. Here, the second, that is a polymer. If there is any polymer exchange, so I told you we call them proton exchange membrane fuel cell, and we can also call them a polymer exchange membrane fuel cell. So what happening over there? There is a proton coming from anodic side towards the cathodic side, and phosphoric acid is exactly the same thing. Okay, so now I think you have a general idea that why phosphoric acid is used as electrolyte. Now in molten carbonate, what's happening? They act as a carrier of that carbonate ions from cathodic material to the anodic one. And you can see here it's very clear that CO3 to the power minus 2 is just shifting, moving from nickel oxide to that one. Okay. The second point, you should also think about that why we are using nickel here and why we are using a nickel. To answer this question, I'm giving you a clue. You have already studied in your previous classes that there is a lead oxide fuel cell. And if you remember that, it's peanut for you to answer that. Okay, again, I'm repeating the question. Why we are using here nickel oxide as a cathodic material and nickel alloy? Why? Okay, basically nickel and nickel oxide, they are the same thing. In the anodic material, you are using nickel alloy or nickel alone. Another side, as a cathodic material, you are using a nickel oxide. So why we are using oxide over here? Okay. And the last one you see here, there is oxygen in the ionic form is shifting from cathodic side to anodic one. So now you can understand that. So which now what's the basic purpose of discussing that? Basically, if you want to focus only on that sectors that you want to study here in this region, that is the shadow area which is covered here, that is electrolyte, then it's really very interesting that you only focus on the hydroxyl ion transfer. For example, if you are preparing a membrane, so what's the ionic conductivity of that membrane? How much proton it can shift? That's your basic goal. So basically these are the things which seems to be a smaller and minute, but they have a larger impact on the research side. So that's very interesting as well. Okay, now we want to move further. And basically in this slide, they just tell you about the tolerance level of your fuels. Okay, if you are working an alkaline fuel cell, proton exchange, and phosphoric acid, and molten carbonate fuel cell, or solid oxide fuel cell, they just summarize is only a few one, but there are also a lot, many more beyond that. So I cannot just discuss all of them, but I can just taking some of them. Let's suppose you can see here. Okay, before discussing that, uh, in order to understand it quite well, I will give you an example. We have a very general term that is called MCL, if you remember that. So basically MCL, maximum contamination limit, or maximum permissible level. If we are studying any toxic chemicals, okay, if you don't have studied it till now, I'm just switching from that example to another one. uh, I'm sure that everyone have heard about overdose. So what is the overdose? Basically, there is a limit that beyond that, that's not allowed. So same is the case with MCL, that if you are using any chemicals in any industries, are in a lab, and there is something coming out of your lab, there is a limit for that. That is Environmental Protection Agency have defined that limit, that beyond that limit it's not allowed. For example, I'm giving you the example of mercury and heavy metals. So some of the mercury, some of the heavy metals, the permissible limit is 0.5 ppm, that is half ppm, and for some it's 2 ppm up to 5 ppm, and that's in the case of mercury. It may also vary from country to country. If you go through different environmental protection agencies like European, American, so the American Environmental Protection Agency, they have just defined the mercury MCL level 0.5, and for European Union it's 2, and for other third world countries it's 5. So it means there is also a big difference in the human nature. If you are living in a country that's not advanced country, so it means it's okay, there's no problem if you are your body is exposing to some toxic chemicals, nothing will happen to you. Okay, I really don't understand that kind of schemes and that kind of policies till now, but still it happens. You can go and browse your internet and find out the MCL level. So MCL level for European Union will be different from American, and that will be different from Chinese, and that will be different from any other countries. I don't know the basis for that. Science is science. It should be same everywhere. A human being living in South Africa, a human being living in Nigeria, Saudi Arabia, Russia, and in the European Union, in any country like Germany, France, and anyone who is living in the China. So Allah Almighty had made his body the same. So when the body is the same, the requirement is the same. How is possible that the toxic chemicals value is different from here and that is from there? That is just nothing but only some signs of alarming sign to this world. Okay. Okay, I should stop here this discussion because that's really very, that kind of discussion give a lot of pain to every human body, and to mentally disturb every human body on that basis, that being in a scientific community, when you are going through different data, and that's not a data individual. Okay, if there is any research paper published by any single human body, we have no problem with that. But if there is any SOPs, and that SOPs is from any organization, and that organization is not just made by 4 or 5 people, that is across the country, and that is the world leading countries, and they are making different protocols for different countries. So that is alarming to this. That may be the death of the universe. Okay, so you can just whenever you know about that kind of things, that there is a contamination, maximum contamination limit, or maximum permissible limit for everything. So same is the case for fuel. For example, if you are working in a fuel cell, and that fuel cell is alkaline fuel cell, just focusing on that, and your fuel containing carbon monoxide more than 0.2%, you cannot use it. That is not permissible. You can cancel that. You never expect a high efficiency from your dead device by using a carbon monoxide content greater than that. They don't have the tolerance for that. And that we had discussed in alkaline fuel cell, if you remember. The second, again, there is a carbon dioxide. Now, if you just compare, it is 100 to 400 ppm, okay, or 0.5 to 5%. Now, if you look here, for 0.5 to 5%, it means the carbon monoxide and carbon dioxide ratio is 1:10. You can think about that, why carbon monoxide is much more toxic in that sense, okay, much more toxic for alkaline fuel cell than carbon dioxide. Why? Now here, if you are working as a proton exchange, then sulfur content is not allowed. Then again carbon monoxide, and then now these are the, but the, the total story become change, the total scene become change whenever you are working, coming to another side, and that is just methanol fuel cell. So, but if you are shifting from that alkaline fuel cell to molten carbonate fuel cell, it means that you are coming here. Now, the carbon monoxide is used as a fuel. That's really very strange. And that is why I had put the question in the previous slides, that what's the reason and why we are using carbon monoxide as a fuel. Okay. So something is very toxic somewhere, but it's the same thing used as a fuel. That's the chemistry, and that's the beauty of that nature. You can just look here. So here, it's just remind me something, that sometimes you see that some things is very dangerous, but inside that there's a lot of benefits for you. So I just remember one of the verses of the Holy Book of Allah Almighty, that Asa an takrahu shay'an wa huwa khairul lakum. Sometimes you don't agree with something, but there is a lot of benefit for you. Sometimes you are in pain and you feel uneasy, but that pain and that uneasiness and that tension and frustration is for your benefit. So everything in this world which is happening to you, being as a Muslim, there is some reward for you. So don't be discouraged, don't be disappointed by some of the environment problems and some of the other problems, your personal problems, your family problems. Just be hopeful that the decision of Allah Almighty is for the favor of the human beings every time. Okay, so if you just look at here again at solid oxide fuel cell, again it's used as a fuel. So that there are some interesting information in that. That is why I just share here. Now there is a question, and the question is which kind of cathodic material or anodic material we can use, and we have that problem. Of course, that's not a universal data from where you can just take that carbon monoxide, the ppm is less than 0.2% will be toxic in every case. That's not the case. Okay, so okay, so you can also look here at ammonia, which is a toxic chemical. So ammonia, and it's really very poisonous. Not only poisonous for human body, it's also poisonous for the proton exchange membrane fuel cell. You can see here, and the values change. And I'm sure that now you have a general idea that why the value of that different chemicals, the level of tolerance is varying from system to system, and why its function is varying from system to system. Okay, so generally we cannot say that methanol is the best fuel, but we can say methanol is the best fuel for a specific system. The second point, that we cannot say that carbon dioxide is a dangerous thing. Carbon dioxide is a dangerous for alkaline fuel cell, for some other, but it's used as a fuel. for molten carbonate fuel cell. So that's the total. So everything that what we are discussing in this world is relative. Why something is the best fuel, why something is a bad fuel. So there must be a clear-cut identification and clear explanation for each and everything, that why we can say that this fuel is the best one. There is no general statement for any kind of fuel or for any kind of system. There must be some connectivities and relativities with two things. Now, naturally, we know that there is a fuel that we had discussed before, that we can use a variety of fuels. And the basic mechanism of that fuel, that you know that these fuels coming out, from outside, in case of if you are taking the example of Bacon fuel cell system, Francis Bacon fuel, that he had only used the hydrogen. Then we also know that there is some other kind of fuels we can use, like carbon dioxide, like methanol, like ethanol, like ammonia, some other fuels we can also use. So whenever we are using that, basically the whole mechanism you should keep in mind. There is a many step mechanism that's happening on the electrodic surfaces. The first step, that your fuel is coming from that reservoir. That is the first thing. And they are coming on the surface. That is the first step of that electrodic material. The second, there is a chemical reaction. And I told you that chemical reaction is nothing but just activation of your that fuels. And what's that activation? Now here you can understand the point, that why some of the fuel cell, they can work at 60-70 degrees centigrade, while some fuel cells, it's work more than 650 degrees centigrade. So the point over here is this one. They need excitation. When your fuel comes from the bulk, they need excitation. And that excitation is, of course, is a chemical reaction, that you are going to excite something, so they need heat. And that some chemicals, they need less heat, and some chemicals need more heat. And then after that excitation, your that fuel particle must attach. Sometimes I'm just using the terms which are not quite relevant. So I'm really sorry for that. So because the particle for fuel, particle, it's not a relevant term, that's a fuel. If I'm using hydrogen, so one hydrogen molecules, so that hydrogen, that molecules of that fuels is going to attach on the surface of our catalyst. That is on the active side, not on every surface, on the active side of our catalyst, and we call them adsorption process. And then after adsorption process, there must be an electron transfer. And that electron transfer is the basic purpose of our fuel. That is the oxidation reaction. Okay, so there is the first step is coming from the bulk to the surface. The second is activation. The third is adsorption. The fourth is electron transfer. Okay, when electron is transferred, that is the fourth step. The fifth step is that is desorption. And the sixth is the deactivation, and the seventh is going back to the bulk in the form of byproduct or in the form of some products. So that is a total, basically a total 7-step mechanism of any fuels that are happening on the electrodic material. Once again, I'm repeating that because it's really very important in every perspectives, particularly for your research levels. Sometimes you are getting confused that why we need such high temperature. Sometimes you just confused about that. So whenever you want to explain every terms in the fuels and in the fuel cells and in the electrodic material, so if you really understand that, then they can open a lot of windows for your research. So the first one, your fuel is coming from the reservoir to the surface. The second one, when it reach here, this fuel system is going to heat. You have to give a heat to the system. So there must be excitation. So that excitation And for all those students who are studying physical chemistry, they understand that what's equilibrium and what's that excitation. And in the previous presentation, where we had studied some particular disturbance in the equilibrium and what is the impact of disturbance equilibrium on the current and on the voltage, you can easily understand now. So that is the second step, that your gaseous or your liquid fuel is going to get excited. The third one, it will get attached on your active side of your electrodic material. And the fourth one is your electron transfer mechanism. And the fifth one is now the detachment. It's time to go free because they came for a purpose and now they achieved the goals and have to go back now. So that is the fifth step, desorption. And then after desorption, there's a de-excitation again. So, and it's again goes to the bulk in the form that, in particular, the fuel cell, I had given you the example of water or some other small molecules, but they may be varied from system to system. That we had just opened a window. Now it's not a window, it's there are different small windows that you can look at it. That you can, on one side you have alkaline fuel cell, on other side you have solid oxide fuel cell. Both are at the extremes. One is working on the low temperature, second is working at the high temperature. And alkaline work at 70 degree, solid oxide work in more than 1000 degrees centigrade. So that's a big difference. Okay, so now the point is how we can process a fuel now. That's our second discussion. So in order to process a fuel, they need different procedures. Okay, there's the next slide. I have devoted this slide because we have natural gas. And we know that natural gas, they contain sulfur. So we need a desulfurizer. How to do that desulfurizer? So remove the sulfur-based compounds, that's called desulfurizer, and we are using some chemical reactions and some chemicals. There's a complete method is given over here. You can look here. That is the method: hydrodesulfurization or selective adsorption. Okay, those students who want to continue some of their research work in adsorption, so that is a really interesting term for selective adsorption. What is meant by selective adsorption? Basically, if you have 5, 6 compounds in a container and you are adding some adsorbent, some material which have the ability to remove these chemicals from that container or from that beaker, and they only pick one compound and leave 5. So we call them selective adsorbent. And the role of that selective adsorption is fabulous. It's really very interesting. So you should know about these things. Sometimes we need to remove a specific thing. We don't want to remove each and everything from your container. So that's very important. So then we have a steam reformer. Then what's a reformer? That is a steam reforming. That is partial oxidation and autothermal reforming. So these are also the term partial oxidation. For example, if you are taking a carbon dioxide, okay, and you want to remove that oxygen. So there are two steps. In one way, you can just consider that we had just nature where all the oxygens it contain. That's complete reduction. But there is also partial reduction, that you remove one oxygen and then you remove another one. The second way you can also do, you can play in some other ways, that you have to add one oxygen atom to one carbon atom and you got an ideal product, carbon monoxide. Now that is oxidation, but that's a partial one. Then because it has still capacity to adjust one other oxygen, carbon dioxide. So these are the terms that you should keep in mind. Basically, I'm taking very basics. But if you take any research paper, they will give you a lot of information regarding that. I'm just opening a window for you and you can go and study it by yourself and you will get a lot of things from that. Okay. And then we have shift reactor as well. and the CO carbon monoxide removal and CO2 scrubber. Okay, okay. Now coming from top to bottom, you see that there is a long way to go. But every kind of fuel cell do not need to go there. Sometimes people ask the question that okay, if some of scientists they claim that alkaline is the best one, why there is a phosphoric acid fuel cell? Why there is solid oxide fuel cell? So the answer is very easy. I think that everyone of you know that because we have natural gas. So natural gas have a long way to go. If you just reach here, you can directly use here. But if you reach here, you can use here. So basically, everything has some benefits. So you should keep in mind the benefits and the drawbacks of each and every system. And for particular system, we can use a particular system. For particular system, we can use a particular device. So that's the basic goal. And then we have the ability to just overcome the energy deficiencies. Otherwise, there is no single assemblies for the whole world that can be generalized and can say that it's the best solution for everywhere. Okay, the thermodynamics of any chemical reaction is very important. Basically, you know about the chemical reaction that is happening, that is overall reaction in the fuel cell. That is a general one that we had studied last time. And particular reaction at cathode and anode that is given, that is anode, and that is fuel cell reaction, or we call them fuel cathode reaction, and that is oxidation, oxygen reduction reaction, that is oxidant at cathode. Now, for an electron, the electrical work performed is NFE, where N is the number of electron, Faraday is the constant, and E is EMS, where F is the Faraday constant, E is the cell voltage. Okay, this represents the action of moving an electrical charge through electrical potential field. Now, under reversible condition, when there is no current flow, then maximum electrical work is performed. That is NF E naught. Okay, that is when there is no when there is no current flow, where E naught correspond to thermodynamic cell voltage. Okay, keep in mind thermodynamic efficiency is a little bit different from general efficiencies. Okay, so you should keep in mind that when maximum work is performed, corresponding change in the free energy, that is free energy available, is minus NF and E naught. You should just remember that formula. That's very basic formula. That is why I don't want to discuss details of that formulas. Okay, but here is something very interesting for you. Basically, the free energy, that is delta G, which is given over here. So, okay, that's delta G. Free energy is the measure of affinity and direction of the reaction. They can tell you if they can give you a negative value, so it means the reaction is going in a forward direction. If they give you a positive value, it means in the reverse direction. Okay, uh, for a cell working in a galvanic or fuel cell mode, energy released from electrochemical reaction delta G is negative, and we know about its very general rules. Okay, if you have any confusion or any queries regarding that, you can discuss with me in the discussion section. The reaction enthalpy and entropy must also be considered to describe the efficiency of electrolytic or galvanic processes. That's also very important because at the same time you cannot only say that delta G is important because delta G is related with the delta H and T delta S. Both of them are also important. So it is the reaction enthalpy and the entropy. Okay, must also be considered. Okay, enthalpy is the heat delivered by the reaction. Negative heat is given out. Okay, as for more of the galvanic process. And entropy describes the change in order associated with the reaction. Now, positive with increase in disorder and randomness of the system. So that's the general equation and well-known equation related to delta G, delta H, and delta S, and you should remember that. Okay, okay. For general, if you just look at here, this delta H value must be smaller than this one. Okay, When the value of this is smaller than the whole, that is temperature times change in entropy, then you have delta G negative. That is a feasible reaction. Okay, otherwise it's not a feasible one. But the interesting one is the reaction will decrease in disorderness, that is a negative delta S. So we have two situations now of delta S. We have a positive delta S and we have a negative delta S. The positive delta S means change in entropy, randomness. So entropy is going to increase. It's a positive value. And there is also a possibility of randomness is going to decrease. Uh, Now, how is possible? That's really very interesting that once I was performing an experiment and my delta S value was become negative and I was shocked. It's it's not going to be negative. How is possible? And there was one senior professor who guided me that no, basically the general rules for this universe is entropy of the system is going to increase. Okay, but entropy it is decreased in chemical reaction. For example, if you are on one side you are using hydrogen, on another side you are using oxygen. Both of them are independent and they are different entities, but when you are going to combine them, it means you are decreasing the randomness, so you will get the delta S negative value, because before combining they have more entropy and after combining they have less entropic level. Same is the case whenever your material is going to attach on a surface, so this attachment is the decrease in the entropy level, so that is also very important. Okay, here they have again given the example that the reaction of hydrogen with oxygen to form water, delta G is less than delta H. Okay. Now the change in entropy is manifested as a generation of heat associated with the conversion of some chemical energy in the fuel. The thermodynamic efficiency is given by this. You can easily understand that this is thermodynamic efficiency is delta G by delta H. Now, from the delta G, you know the value of delta G. You have just put the value of delta G. That is delta H minus T delta S. If you put the value of and then divide every term by delta H, so you get this one. So that is the final, that is thermodynamic efficiencies. Okay. Now, the interesting is, since for most of the reaction, entropy change is negative. For most of the reaction, entropy change is negative. The thermodynamic efficiency is less than 100% and can be seen in the next table. There is a table that I will show you in the next slide. There is, for most of the chemical reaction is less than. However, in some cases, the reaction result increase in disorder. Okay, so when increase, that is positive delta S. For example, formic acid. So then at that system, and the system takes heat in from the environment, so expressing efficiency of greater 100% based on thermal efficiency of the definition. Okay, so that is just according to this their definition. You can see here, if you are using hydrogen as a fuel, chemical reaction will be this one, and you have minus delta H, the value given. Number of electron transfer is 2 electron transfer per chemical reactions, and you have delta G, that is negative delta G, this one. So feasible reaction, and you have cell voltage, and you have the efficiency 83%. Okay, slowly and gradually, if you are using methane as a fuel, so the basic chemical reaction of the methane will be this one, that is methane is going to convert in with oxygen and they can give carbon dioxide. Keep in mind, using methane as a fuel, you have carbon dioxide generation problem. You are producing carbon dioxide, that is a toxic one, and you can look, it needs a, that's 8 electron transfer. Now you can just only compare that if there is 2 electron transfer, if there is 8 electron transfer, what will be the effect on the current and voltage. Now here you can see that's minus delta H, enthalpy change is this one, and the entropy, but the efficiency, I'm just interested in the efficiency, is 92%. If I'm using methanol as a fuel, then we have 97% efficiency. But if I'm using formic acid, then we have 106% efficiencies. Okay, so that's very interesting. That's why we have 106% efficiency over here. I think till now we had discussed some things the basic aim of my this today presentation, basically the target was to discuss something about methanol fuel cell or ethanol fuel cell. But I have already taken a lot of time in discussion some of the basic terms and some of the supporting materials and some of the supporting chemical reactions or terminologies that which I strongly believe that's much more beneficial for the students at every level. And we cannot deny this fact that basic is the most important for every chemical reaction. So that is why I had given a lot of time to their discussions. And I'm afraid that I'm just exceeding the time limit. So I'm stopping over here, and by the inshallah, if we have life, and if our life extended and Allah Almighty had given us a chance, then we will discuss something more about the fuel cell. And we will discuss a methanol fuel cell, and if we have time, we will discuss the ethanol fuel cell, and that stepwise, slowly and gradually. Continue your study, and best of luck. Assalamu alaikum wa rahmatullahi wa barakatuh.